we also feel privileged that our respected Sattar Mandal sir is continuously moderating this webinar series for us. So in this continuation, today we have Professor James Lowenberg-DeBoer, who is a leading scientist and economist in the world of precision and digital agriculture. So we are very happy to have you with us. Welcome, Professor, and thank you very much for managing your valuable time for us in this afternoon, morning your time. So I think Bangladesh is very much interested in precision agriculture and this agri-tech. But we have obviously lack of knowledges. So from your today's lecture, hopefully we'll enrich our knowledge, and to some extent we'll try to apply this new branch of new branch of agricultural science in our own agriculture. So welcome you again. And I also would like to welcome Professor who is Alamin. Maybe some other professors are also joined with us.
From Harper.
Professor Professor Carl from Harper University. He is with us. I can see him. And Professor Bruce from Purdue University, and Elias Martin from Italy. Our teachers, our colleagues, scientists from different institutions, students. I welcome you all to our today's webinar, and hopefully you will enjoy this webinar, and all of we will learn something new from this webinar, James' lectures. So with these few words, I would like to hand over this the rest of the session to our moderator, sir, to continue further. Over to you, sir.
Thank you very much, Hasneen. It's a great pleasure for me to moderate this session. And as you told yourself, that I have been enjoying doing this during a very difficult time, the last 2.5 years. And one of my sources of pleasure or encouragement is that the technology, particularly this internet technology and then Zoom and then virtual devices that University Grants Commission allowed us to use through the BD-RAIN services, really. And at the beginning, we didn't have all these opportunities, but at the time passed, our facilities expanded. I remember on the 20th of April, 2020, when COVID just began, and I started joining this kind of virtual meeting. I had a limitation of only 40 minutes from Google's usual allocation, but then now we can continue for hours, 3 hours at least. So it's a great step forward. Okay, and then the second thing I would like to draw your attention to is that our way is something like that. Usually it's a 2-hour session, but then we can spread a little bit more if it is needed. So there is no hard and fast rule about it. And usually introduction to the speaker and some description around it. And then the presentation would take about an hour, and the rest 1 hour will be spent for comments, questions, or hour. So Professor Lowenberg-DeBoer, please don't hesitate to extend your time if it is required really, because we would love to hear from you on some of the very recent um, uh, technological improvements or the methods really, like this smart farming, the precision agriculture, the digital agriculture, and so on and so forth. And these are very much reported in the mainstream policy documents of the government of Bangladesh. And particularly the ongoing 8th five-year plan mentions it in different places, all these smart farming, precision agriculture, digital agriculture, and then sustainability and so on really. And we also have these documented in the Ministry of Agricultural Policy 2020, where it mentions these high-tech, improved technologies for accelerating growth in agriculture, particularly in crop sector agriculture. So you'd very much love to hear more of the technical and then economic aspects of this technology. So please feel free to express yourself or illustrate your examples. Okay, before I invite Professor Lowenberg-DeBoer, let me introduce him through a short bio that I got from him. Professor James has a very checkered career, professional career. He holds the Elizabeth Crick Chair in Agri-Tech Applied Economics at the Harper Adams University in the UK. He is responsible for economics in the hands-free farm. This is another new terminology that we hear now. Economics in the hands-free farm, or abbreviation HFF team. There is a team on hands-free farm at Harper Adams, really, and he is responsible for that. He is also co-editor of the famous journal we know, Precision Agriculture. And he is also the past president of the International Society of Precision Agriculture. This is called ISPA. His research mainly focuses on the economics of agriculture technology. Especially, he mentioned precision agriculture and crop robotics. This is something we'd love to hear, really, that we hear very much crop robotics. Lowenberg-DeBoer's research and outreach is founded in hands-on experience in agriculture. That's what we love to hear from you, and including production of maize and soybeans in Northwest Iowa state in the USA. And before I hand it over to Professor DeBoer, let me spend a couple of minutes really giving an idea about this Bangladesh smallholder agriculture. It's smallholder agriculture in the truest sense of the term. It's really small in terms of size of plots or size of farms, really. The average farm size is 0.3. Average farm size in Bangladesh is just less than 1 hectare, but then is split in number of fragments scattered all over the villages or fields, really. And sometimes they are in distant places as well. And the implication of that in the first hand, it might appear that may appear as an obstacle for the use of lumpy, big size machineries, really. But the history has proven that most appropriate type of technology, appropriate to farm size and fragmentation, are also available already through the introduction of the Chinese origin diesel engines, and now the other sorts of machines like irrigation engines, and then power tillers and four-wheel tractors, and then latest, the combined harvester, but certainly of medium scale size or anything. So that's the one thing. In terms of number, we have 17.5 million smallholder farmer in Bangladesh, and they include not only crop farmer, but they are by and large is mixed farmer. They also rear animals, cattle animals, and then some of them have homestead small scale dairy, and some household level poultry farms, and then fish ponds as well. And major crops are rice, the cereal, but we produce a little bit of wheat, but wheat constitutes only some 15% of the total demand of the country now. It's roughly 1 million tons, but Bangladesh is now consuming roughly 6 million tons of wheat. So it's most of it are imported. The cash crop includes jute, the traditional jute crop. It disappeared, but it has begun to appear again as a good profitable crop. But there has been also reasonable level of diversification in farming system. We have now expansion of orchard, particularly of fruits. And then mango is the main one, but then there are guavas, and then there are citrus, the new crops. That's one element of diversification. Other elements of diversification, there has been commercial farming with fish, we call pond aquaculture, mostly inland, but now the country is looking forward to going to the sea as a part of blue economy. And so that Hilsha is there in the sea, but those are all parts of, there is open water capture fish as well, but which is declining in terms of mostly scarcity of water and drying up of perennial water bodies. So in terms of diversification, there's a process is going on. The major element is there is a shift from rice, the most cereal crop, to non-rice crops as well. So that's good for nutrition as well. In many sense, vegetable has been another one really, which has made a kind of revolution really. Okay, I think given this small introduction about Bangladesh agriculture, which is transforming very fast, and major driver to this transformation process in the crop sector has been the small scale irrigation with the Chinese origin diesel engines, which are used to withdraw and pump water from the underground. And that has become a big question now, and also from environmental point of view, from a cost and energy point of view as well. So there is a question of energy, irrigation energy nexus as well, really. There are many other issues. But the good thing is that in the smallholder agriculture, there has been an irrigation water service market, which has developed in the late 80s and early 90s, and now is expanding to other consequential kind, I say consequential kind of market, like market for tillage or tractor services, market for rice planter services, market for threshing of crops, and then finally market for combined harvester services. So let me stop here. Thank you very much indeed. I think it helps. I would now request Professor Boer to make your presentation. So Professor DeBoer. Thank you.
Thank you very much, Professor Mandal. Thank you, Professor Jahan and Professor Mahbub and all you distinguished ladies and gentlemen. I'm going to share my screen, and I hope this works.
Yeah, I can see.
Okay, great. Excellent. So thank you very much. It's great to be with you. I wish I could be there in Mymensingh. I remember very positively my visits there during the project with Professor Islam, where we looked at the economics of grain moisture sensing. But today I'd like to address a broader topic of the economics of sustainable intensification for smallholder agriculture. And FAO defines agricultural intensification as an increase in agricultural production per unit of inputs. And those may be various inputs of labor, of land, of time, fertilizer, seed, all kinds of inputs. And the chart on that first slide is sources of growth in global agricultural output. And the big picture here is that before 1960, most of the growth in agricultural output came from expansion of land area as new land was cleared and improved. Over time in the 60s and 70s, the role of more inputs became more important. So seed, fertilizer, pesticides, and that's the sort of tan section of the bar in the chart there. But what I want to really draw your attention to is the green portion of the chart, which is what economists call total factor productivity. That means making better use of existing inputs, land, labor, seed, all of those other inputs, managing them better. And that has become the primary source of greater output that will help us feed the 9 or 10 billion people that will be in the world fairly soon. And you can see that expansion of land, expansion of irrigation, more inputs, all of those are still there, but they're fairly small compared to that improvement in total factor productivity. And that really helps us start talking about the inputs that we need. So what I'd like to talk about today and share with you and eventually to hear your inputs on is, number one, to outline how agri-tech is improving agricultural sustainability worldwide. So to sort of zoom out and get a big picture. Secondly, to summarize how technology in the pipeline that may not be commercial yet, but is on its way, could make agriculture more environmentally and economically sustainable. Envision how that high-tech sustainable agriculture could happen for smallholder farmers, and then to be a little bit more specific and talk about how that might happen in Bangladesh. In this slide, I want to draw your attention to the fact that the same technology might be used at various different scales. So in the two photos there in the slide, the upper photo is a handheld nitrogen sensor that measures the crop needs for nitrogen. In the lower photo is the same technology, the same sensor, but mounted on a large piece of equipment where that nitrogen now is applied to a wide area going through the field. So the same technology, but applied at a very different scale. So let's talk about and start with some basic ideas. So what is sustainable agriculture? In Europe and in North America, agricultural sustainability is often thought of as going back to traditional practices. But we need to realize that many of those practices, like the ones in the photo there, were not particularly sustainable when they were common, and are probably even less sustainable now. The 1987 Brundtland report defines sustainability as the ability to meet the needs of the present without compromising the ability of future generations to meet their own needs. And so agricultural sustainability is not defined in terms of a specific kind of technology, whether old or new, but in terms of outcomes. So improved food security, reduced environmental footprint, healthy rural communities. A few more other definitions that I think we need to get clear in our minds. Sustainable intensification. So it's one thing to intensify. It's also another thing to be sustainable in that intensification, and that's defined as process or system where agricultural yields are increased without adverse environmental impact and without the conversion of additional agricultural land. Precision agriculture, which I've been very deeply involved in for a couple of decades now, is a management strategy that takes into account temporal and spatial variability to improve sustainability of agricultural production. Smart farming and digital agriculture are somewhat broader terms, and they refer to managing farms using technologies like Internet of Things, robotics, drones, AI, which may not be specifically focused on temporal or spatial variability, but are broadly aimed at optimizing production to produce more crops and livestock. Okay. Some key technologies in this area, and I cover this because I realize that in the audience there's a range of knowledge about agricultural technology, that some of you know this very well and others may not know it in quite the same detail. But precision agriculture technology includes global navigation satellite systems, and more commonly in much of the world called GPS, so geographic positioning systems, the American system, graphic information systems, there's satellite, aerial, and drone remote sensing, there's more sensors, other kinds of soil and proximate sensors. One of the key technologies is variable rate technology, which applies seed and fertilizer and pesticide at different rates in different parts of fields. And then there's big data, especially pooling data for management insights. Beyond that, smart farming and digital agriculture will include Internet of Things, blockchain, especially for traceability, which can be very important for marketing and consumer use of products, digital phenotyping, and that's especially for plant breeding. And then there's a whole area of precision livestock farming, which I will not talk about very much, but is parallel to the crop production technology. So we think about those technologies in a bit more detail. GNSS light bars were the first step in automated guidance of equipment. And you see there in the photo, the little device in front of the driver with the lights that help keep that driver on track. GNSS guidance was first introduced commercially for agricultural equipment in Australia in 1997 and quickly spread to North and South America. Auto steer technology is the next step where the computer takes over directly operating the equipment, and the human operator is there mainly to take over in case there is a problem. Auto steer is one of the agricultural technologies that has been adopted most quickly and most widely in history, that we can see from in about a decade or slightly over a decade. It went from introduction to becoming standard practice around the world wherever there's motorized mechanization. In terms of sustainability, GNSS guidance affects sustainability mostly by reducing skip and overlap in the input application, so fertilizer, seed, and pesticide. And that you can see there, one of the ways that happens is automatic sprayer and boom control and planter row shutoff. So you can see in the drawings in the bottom of the slide how when a big piece of equipment enters into an area that either needs application or doesn't need it, the application doesn't occur across the full boom, but can be shut off by sections or sometimes by individual nozzles. And this has become very, very common all over the world. Variable rate technology is really, the idea is putting the right input in the right amount in the right place at the right time. And that typically has been guided by maps like the one in the slide, where the different colors in that map show different rates of application. So the red areas are getting a much higher rate than the orange, yellow, and green areas. VRT affects sustainability mainly by reducing over application of inputs in places where they're not needed. But also in some cases, VRT can improve yield quantity or quality by increasing inputs where they are most needed. So it's really a key precision agriculture technology. Yield mapping started with grains and oil seeds, and the first commercial yield maps were done in the early 1990s, but the technology has been extended to most major mechanically harvested crops. And so the yield map in the slide here is a sugarcane yield map from Colombia, where the dark blue areas are the higher yields and the green and yellow areas are lower yields. In terms of sustainability, yield mapping is mainly important because it gives farmers specific feedback on crop production practices. It identifies where the yields were particularly good, and also where the yields were not good, and provides an opportunity for the farmer to focus on those areas that are not living up to expectations. Uncrewed aerial vehicles, also known as drones, are being widely used in agriculture. Essentially, they're flying robots. In most of the world, they're being used mainly for data collection. but the use for site-specific input application is growing widely, especially in places like China and Brazil, where they haven't been quite as limited by regulation. UAVs can also be used to manage extensive livestock grazing, as is in the photo there. At Harper Adams, for instance, there's been some work in using UAVs to guide sheep to new pastures. Autonomous mobile crop machines, also known as robots, have been a large part of the focus of my work at Harper Adams. And in the photos there, you can see that there's many visions for what those robots are going to look like. So up in the left-hand corner is a vision from one of the major farm equipment companies, and that's of large machines that are now autonomous, so that machine no longer has a steering wheel and a cab for a driver to sit in. But in the center there, you see another vision of a swarm robot, which says that, well, once you take the human being off the machine, there's really very few reasons to have very large, heavy machines, and you could have many small machines doing the same work. In some cases, there's been ideas of retrofitting existing machines, and a lot of the work at Harper Adams has been using retrofitted machines that are made to be autonomous, but can still be switched to manual mode, which has a big advantage in moving them from field to field. And then in the lower left, you can see the DOT equipment from Canada, which looks very different and is designed in a very different way from all of the conventional motorized farm equipment. So crop robots of various types are just starting to be marketed in industrialized countries. The most cost-effective robot design is not yet known. We don't know what will be most practical and profitable. Robots affect sustainability mainly by making highly specific data collection and management economically feasible. So especially in industrialized countries, but increasingly in developing countries, farm labor is becoming more expensive, it's becoming harder to find. So intensive management becomes more difficult, and robots may change that situation very dramatically. So if we think about those things that are now being used, and we think about a vision for sustainable food and farming with that technology, and let's start by thinking, okay, what does that look like in the United Kingdom? What we see are more small and medium-sized farms, which in the United Kingdom would mean somewhere in the range of 1 to 100 hectares. And remembering that what we mean by small and medium-sized farms varies a lot from place to place around the world. We see reduced use of fertilizer and pesticides as we use the inputs that we have more effectively. We see farms more directly linked to processors and consumers. So instead of the farmer producing a bulk commodity which goes to a middleman or an intermediary, we see them more directly linked to producing what those processors and consumers want. We see farmers devoting more of their time to management, to strategy, marketing, and entrepreneurship, and much less to doing manual work or to operating equipment. We see more biodiversity within farm businesses and a wider range of enterprises from farm to farm. So we think farms will be specialized, but in a given region, those specializations may vary much more from farm to farm. And we think that farming in rolling topography with many small irregularly shaped fields will become more economically viable. And that's really important for the United Kingdom and Europe, most of Europe, where a history of farming has led to many, many small, irregularly shaped fields that have been at an economic disadvantage compared to the Americas or Australia over the last decades. As we go forward and we look at what's in the pipeline, one of the big opportunities for sustainability is the use of on-the-go sensors. The sensor in the photo is a nitrogen sensor that has sensors mounted on a boom in front of the machine, computer algorithms that then use that sensor information and guide the fertilizer application at the back of the machine. VRT fertilizer adoption has lagged in much of the world. It hasn't been nearly as popular as GNSS guidance, with a few notable exceptions. And we think that that probably happened because both of technology and economic reasons, that the sensors are still quite expensive. The knowledge and information needed to guide those sensors can be costly. It requires usually a human intervention to come up with application maps, and the effects have not been as good in terms of yield and quality as one would have hoped. On-the-go sensors provide a possibility of improving that, of making that application much less expensive and more accurate. Right now, on-the-go sensors are most widely developed for nitrogen application, but they could be developed for phosphate, for potassium, for lime, for other fertilizer micronutrients. Another opportunity for sustainability is machine vision to individualize pest control down to the plant and the insect level. And this is another technology that can be used on various scales. So the upper photo there is of the John Deere Blue River See and Spray technology, where John Deere has incorporated technology into a machine that's mounted on the back of a tractor with a human driver, and that machine identifies specific weeds and sprays those weeds. So instead of broadcast applications, it's a spray on a specific weed, but the same sort of technology might be applied on small autonomous sprayers like the one in the lower photograph. And as we move forward with that technology, it may become so fine-tuned that we would be able to apply herbicides or other treatments to specific weeds, to specific insects, to specific plants that are diseased. And that might be done with large conventional equipment or with robots. Robotic pesticide application may be specifically adapted to farms with very small, irregularly shaped fields like they are in Britain. So if we think about robotics, what do we think about the benefits of them? And usually the benefit of robotics, the discussion starts with farm labor, and farm labor is becoming more expensive and more difficult to find everywhere in the world. But there may be other benefits which are even more important in the long run. One of them is reducing farm equipment investment by using smaller machines more intensively, and I'll give you a specific case of that in a few minutes. It may be possible to reduce and eventually eliminate herbicide use by targeted spraying and mechanical weed control. We think, and we have some good evidence, that biodiversity in fields could increase because robots can facilitate farming small, irregularly shaped fields. And then an issue that often is neglected is what are the rural entrepreneurship opportunities that are created once farm labor is no longer the main binding constraint on farmers. And one of the easiest ways or places to look for that is in organic production, where weeding labor is often a key constraint, but there are others as well. So if we look at that agri-tech pipeline, we see robots are starting to appear in crop fields. And the photo here is AgroIntelli Roboti, weeding robot that is weeding French beans last year at Stratford-on-Avon here in Britain. The only country that we have data from is France, where in 2020, there were 150 robots being used, mostly for mechanical weeding of vegetables and sugar beets. Worldwide, agricultural robots market in 2021 was almost $5 billion worth. If we look at what's on the market, the Future Farming Crop Robot Catalog has 48 robots being marketed by 31 medium and small manufacturers, plus 2 companies with tractors that can be operated autonomously, and 6 companies with retrofit kits to convert conventional tractors for autonomous use. And that's in addition to the robotic offerings of the major farm equipment companies like Deere and C&H, which are starting to commercialize robotic or autonomous crop equipment. At Harper, we've done a lot of looking at the economics of crop robots, and we're able to do this because of the experience with Hands-Free Hectare and Hands-Free Farm. So Hands-Free Hectare started in 2016, so we now have 5 years of experience producing crops entirely with autonomous equipment, where there's no human labor involved. And we've been able to use that and scale that up and say, okay, what if you did that and use that kind of approach on farms of various sizes? So the chart here in the slide shows cost curves for wheat production, and wheat is the most common crop in Britain. So we thought, okay, let's start with that. The blue line is cost curves for wheat production with conventional equipment with human drivers over various farm sizes ranging from 66 hectares to 500 hectares. And the labels at each node is the size of the tractor being used. And traditionally, as farm size expanded, a larger and larger tractor was used. So the smallest farm here is using a 38 horsepower four-wheel tractor, and that goes up to an almost 300 horsepower tractor on the largest farm size. The orange line there is the cost curve with a robotic farm of the type used for Hands-Free Hectare and Hands-Free Farm. There we used a swarm robotics approach and said that we're going to use the 38 horsepower tractor, which is the unit that was used for Hands-Free Farm. But as the farm size increases, we're going to use multiple units. And so the largest farm size here is using 3 of those units instead of just 1. Now, we don't know if 38 horsepower is the perfect size for swarm crop robots. That will be determined by research in the future, but it is what we had information on. The 2 things you need to pay attention to on this chart is that, number 1, the robotic cost curve is substantially less than, so 20 to 30 pounds per ton cheaper to produce. And this is incredibly important in commodity production. So if you can produce more cheaply, you can be more profitable, you can sell your product into the international market. But maybe even more important is the fact that the robotic cost curve flattens out at a smaller farm size. So the roughly 180 hectare farm there, the cost curve by then is almost flattened out, meaning that there's less economies of scale, and smaller and medium farms have a better chance with the robotic technology. The bar there that's shown in the chart is the range of costs for major countries exporting wheat. And we see there that the robotic cost curve in Britain could potentially be below the costs of major exporting countries. And so this means there could be substantial changes in the comparative advantage of wheat production in that market. And not that UK farmers will necessarily produce more wheat. They may find other crops that are more beneficial, but the point is that robotics will affect the trade pattern in addition to the production patterns. This is the slide that farmers are usually most interested in when I talk about robotics to farm audiences. And it is the investment required to equip farms of different sizes with conventional or robotic technology, with the blue bar being the cost for conventional farms and the orange bar for robotic farms. You can see there on the smallest two farm sizes that we looked at, the robotic farm costs slightly more, and that's because of the cost of retrofitting the equipment for autonomy, so hardware and software costs. But for the larger farm sizes, the robotics are much, much cheaper because you're using smaller equipment much more intensively. So on the larger farm size, the conventional farm uses one large combine that costs roughly 300,000 pounds, whereas the robotic farm uses three small combines retrofitted to be autonomous, each one costing roughly 30,000 pounds. So there's a big savings in the cost of equipment. Another thing that we've looked at, and in particular, your colleague Alameen has worked on this issue of what are the economics of autonomous machines in small, irregularly shaped fields. And so we used our linear programming model to estimate cost curves over different sizes of farms with different field sizes. And you can see the original blue and yellow cost curves are still in this figure. And with 10 hectare fields, which is a relatively large field size in Britain. It wouldn't be large in North America or in Brazil, but it's large in Britain. Those cost curves are very similar to what we estimated previously. But when we think of smaller fields, and in Britain, a 1 hectare field would be considered quite small. And with the robotic technology, and that's the red cost curve, you can see there that the costs are slightly higher than they would be with a 10 hectare field, but still, they're still below those of the cost curve with conventional equipment. But with conventional equipment, the black cost curve is much higher than it would be with conventional equipment, and much, much higher than it would be with autonomous equipment. So we see that autonomous machines lowered wheat production costs somewhere in the range of 21 to 40 pounds per ton on those 1 hectare fields. And it's important to note there that for the 1 hectare field, it's only assuming that small equipment could be used. So 28 kilowatt tractors or that 38 horsepower tractor could be used. And in Britain, it's not obvious that labor could be found to operate many, many small units of those tractors. So it's not clear even that 1 hectare conventional cost curve could even be achieved. So we think that the conclusions there is that small fields could be operated profitably with autonomous equipment. So the kind of landscape that you see there in the photo with many smaller regularly shaped fields with hedges around them could be maintained, because having those small fields, having those hedgerows has made biodiversity benefits. So there's wildlife, there's a diversity of plants that live and thrive in those hedgerows that can be maintained while being able to do the farm work cost effectively. So this would diminish the pressure for field enlargement, which there has been a lot of that in Britain, and would allow achievement of some of the government goals of environmental management and greater biodiversity at the same time as allowing farmers to be profitable. Another part of the discussion in Europe is about regenerative agriculture, to include many more practices that include more biodiversity in fields, and agroecology innovators have suggested many different cropping patterns, pixel cropping, patch cropping, strip cropping, and you see there in the photo at the right an example of a pixel cropping pattern that is being tried at Wageningen University in the Netherlands, with many small crops, patches with different crops. Because of differences in plant height and growth pattern, it's become an engineering challenge to automate that. And especially in industrialized countries, but even in all around the world where labor is becoming more expensive, automation is crucial. We think that strip cropping is probably going to be the initial start of some of that alternative cropping geometries. And so we did a little bit of looking at the economics of that, and we applied this first to maize and soybean cropping in the Midwest, because they had some of the best agronomic information involved. And we found that and this was on a large farm size, so 2,000 hectare farm in the Midwest, but that strip cropping of maize and soybeans had a potential for substantially higher returns to operator management and risk taking. And that's some work that Al-Amin is continuing, and we hope to have results both for the US and also for Europe on the potential for that approach. If we think about farm enterprises that could be more economically feasible with robotics and AI, I've mentioned organic crops of all kinds, because weeding labor is a key constraint. And in much of the world, consumers would prefer to buy organic produce, but they don't want to pay a premium. So if you ask consumers in Britain or in North America if they want to buy organic produce, a very high percentage of them say yes. A smaller percentage of them actually buy it because there's a premium involved. But if farmers could produce organic products of equal quality for a price that was not higher than conventional methods, there's a big market opportunity for organic products. But in addition, there's producing heirloom varieties and species that don't adapt very well to conventional mechanization. Maybe they're too tall, or they lodge, or there's some other issue. There's the potential for producing small amounts of grains, oil seeds, and other crops with specific characteristics. For instance, if you had a producer, a consumer that wanted high omega-3 content oilseed rape, you could produce a small amount of that with at a low cost with autonomous equipment. And there's also potential in herbs, flowers, medicinal plants, and then there's a whole area of livestock production with in extensive grazing that has many, many opportunities. But non-mechanized smallholders, farmers, the challenge has been the lack of technology. Almost all of the technology that I've talked about so far is being used mainly by farmers that use motorized mechanization. And there's good data from the United States, especially, that suggests that smaller farmers in the US are starting to use precision agriculture technology. It takes a little bit longer for them to start using the technology because they often rely on used equipment. And so they don't go out and buy the new equipment, but when the technology now comes into the used equipment market, they use it. But for non-mechanized farmers, that's a real issue. And usually this means having some kind of adaptive research that adapts that technology, takes it, the basic idea, and puts it in a form and with a business model that fits to the more local conditions. Some of those requirements include better information for pest and soil fertility management. There's AI systems that serve the needs of smallholder farmers, help them do practices with the right inputs at the right time in the right amounts, and then labor-saving systems for small farms. One of the technologies that's starting to come on the market are handheld sensors, and particularly there's been some developments in terms of measuring plant nutrition and soil nutrition. You can see there a smartphone with an app from Soil Cares, which has been one of the leading organizations in that region. Research has shown that there's a potential for handheld nitrogen sensors on medium and small farms, but the cost of the sensors has been too high. The cost of the nitrogen sensor that I showed you in one of the first slides is about $300 US, which is too high for most small farmers. And so one of the hypotheses, and this is a hypothesis that actually is based on some of the work that Professor Islam and I did on grain moisture sensors, is that to achieve widespread use, that nitrogen sensor should cost probably less than US $10. And a corollary hypothesis is that to achieve that price threshold, the sensor will probably be a cell phone app or some kind of cell phone accessory. Many smallholders in developing countries need technology for tropical tree crops, and this would include oil palm, natural rubber, tropical fruits, mangoes, guava, bananas, mangosteen, tropical nuts, cashews, coffee, cacao. The photo there is of a selective coffee harvester that was developed by the Columbia Coffee Growers Federation and the Bruden Company to reduce labor requirements for harvesting high quality coffee. Examples of the technology that's needed are pest and soil fertility. So again, this idea of right place, right time, right amount, right product, and then labor saving devices for pruning and harvesting. Machines for rubber tapping, and colleagues at Harper have worked a bit in Thailand, and there The ideas include tapping machines that are connected to the trees, and also robots that go from tree to tree to tap rubber. One of the big issues is the potential for robots in developing countries. And the photos here are of rural countryside in West Africa. One of them is from Wudil, Nigeria, and Donsan. The lower one is Donsan, Burkina Faso. These are both places where I spent a lot of time working with local scientists. And the conventional wisdom is that in order to deal with the higher cost of labor and the difficulty of finding labor, that they should go to conventional motorized mechanization. But motorized mechanization requires large rectangular fields to be really cost effective. What if we could use robots? And we've already shown in Britain that autonomous machines can be cost effective, can be profitable on small, irregularly shaped fields. What if we had a robot that could be productive in hand weeding, planting, harvesting, and was available for the equivalent cost of a motorbike? In Africa, and I think maybe in Bangladesh as well, there are farm families that have motorbikes, so it's not totally out of their budget. That kind of robotics could reduce the pressure to totally redo rural landscapes, because that's what's happened in some of the places where motorized mechanization has been involved. So trees were removed from fields, fields were enlarged, in some places even villages were moved to allow for fields to be larger size. One of the other ideas to deal with rural infrastructure problems is using drones. Instead of just using them for data collection, we could use them for deliveries, and this is already being done in Africa, and it's been tried in Britain as well for delivering medical supplies to remote clinics. What if the cost of the drones is reduced, capacity increased, and we could use drones to deliver veterinary supplies, seed, pesticide, fertilizer to isolated farms? This would make them much less vulnerable to infrastructure problems and road issues and so on. Satellite aerial drone sensors could provide early warning for insects and plant diseases. Large farmers often use sensors to monitor their fields. Small farmers often know their fields quite well, but they don't know what's coming. They don't know if there's a plant disease that's maybe just a few fields away and is coming their direction. So sensors could help provide early warning, and with systems that now are putting up many small mini satellites and provide frequent updates on that information, this becomes more and more possible. Purchasing and marketing online already is quite common in the US and Europe, and farmers find that beneficial. Gives them often lower prices and a wider range of products. Farmers in the developing world, now many of them have cell phones. Soon many of them will have internet access. They could also buy inputs and market outputs, output with their cell phones or with their smartphones, and then achieve some of those benefits. And the photo there at the top is a farmer in Kenya using the mFarm app to help do that. One of the most desirable potential outputs of using agri-tech is high skill employment in rural areas. And we know that large-scale mechanized farming requires substantial expertise and enormous amounts of capital. We might see that shifting somewhat to precision farming, meaning we're using still quite a bit of capital, but enormous expertise. We're increasing the role of expertise. We know that some of that expertise could be outsourced via the internet to distant sources, but there's also always the importance of having local knowledge, and internet access and electronic tools will allow rural businesses to be more competitive. So, okay, so we see there's potential to use agri-tech in smallholder agriculture. What can we think about in terms of using that kind of technology in Bangladesh? So we know, and Professor Mandal gave us an overview of the current situation, but we see that in Bangladesh, the country is largely self-sufficient in rice and vegetables, but imports many other food products: wheat, cooking oil, pulses. There's been great success in the mechanization of primary tillage, mainly with, especially with two-wheel tractors, but also increasingly with four-wheel tractors. And you can see there in the chart that Dr. Rahman and colleagues have put together that the land preparation, the blue bar there at the bottom, is close to 100%, that it's become quite rare to see draft animals being used in Bangladesh. But if we look at other crop production, we see that some of that is mechanized, but not necessarily motorized. So the pesticide and herbicide application, if I understand the data correctly, mostly uses knapsack and handheld sprayers that are hand pumped. And very little of that uses the kind of boom sprayers that I've shown on other being used in Europe and in North America. Threshing also is partially mechanized, but still a substantial part of that is hand driven. But what happens now if we see that labor is more expensive and harder to find in Bangladesh as well? And we know that small-scale motorized planting and weeding and spraying and harvesting equipment is available. It's certainly available in the region, and there's been a lot of work, particularly in China and Japan, on this kind of equipment, but it's also available in Bangladesh, but not necessarily used. If we look at the labor side in Bangladesh, the chart on the left shows the percentage of the labor force in agriculture, and the lighter blue line indicates what's happened in Bangladesh. So in the period from about 1990 to now, that's dropped in Bangladesh from about 70% to under 40%. And this is the most rapid drop of the country shown in South Asia there on the chart. You know, the percentage of labor is dropping everywhere, but in Bangladesh, because of development of industrial production, particularly the garment industry, but also others, it's dropped particularly fast. And simultaneously, the real wages in the rural sector have been increasing. So the bar chart on the right is real wages by sector in Mymensingh. And the blue bar is farm wages, the orange bar is industrial wages, and the gray bar is construction. We see that in the earliest date on the chart, 1995, farm wages were much, much lower than either industrial or construction wages. When we see the 2014 numbers, which are the most recent in this particular study, the farm wages are actually slightly higher than the industrial wages and not very far away from the construction wages. So there's been a big increase in real wages of farmers, and that means to maintain the financial viability of farms, they have to find ways to become more effective. As Professor Mandal suggested, Bangladesh has many, many small farms, and the percentage of farms, small farms under 1 hectare is growing. So you can see the blue bars there. Over time, are an increasing percentage of total farms. The percentage of the larger farms is about the same, 9 to 10%, and the medium farms are decreasing. And the size of plots on those farms is very small. So if we look at the small farms with 800 square meters as being a typical plot size, this is a very small plot size for most conventional mechanized equipment. And even the size, the slightly larger than 1/4 of a hectare on the larger farms is also a very small plot size for most conventional equipment. So if we think about the broader picture, digital Bangladesh has set an ambitious goal to graduate from LDC status by 2026, become an upper middle income country by 2031, and achieve high income status by 2041. Transformation of agriculture is a key part of that strategy, and that's highlighted in the National Agricultural Policy of 2018. It's needed to achieve the Ministry of Agriculture vision of sustainable, safe, productive, profitable agriculture. And there's many initiatives to try and utilize existing agricultural technology to achieve that. But agricultural technology is constantly changing, and it is essential to be aware of innovations on the horizon so as not to get locked into an old technology. And this is something we discuss all the time in Britain. We don't want to create policies which lock farmers into old technology when there are new technologies that would enable them to be more sustainable, to be profitable at the same time that they preserve biodiversity and reduce overall chemical use. So a vision for Bangladesh agriculture looking beyond current technology. And that vision, at least for me, really is small-scale, low-cost robots working with farmers to intensively manage crops. We see a diversification in cropping systems with alternative geometry, and certainly strip cropping, relay cropping, patch cropping, all of those are potentially possible. We see a combination of robotic, mechanical, or targeted herbicide weeding and greater field diversity, enabling higher yields with lower pesticide use. And farmers producing a wide range of higher value products, not just rice, but all kinds of products, marketing electronically directly to processors and consumers. So take-home message, and thank you for your patience here. We see that precision agriculture and other agri-tech innovations are already enabling the world to produce more food with less input. But most of that current technology is only available on farms using motorized mechanization. We see also that technology in the pipeline, so on-the-go sensors, crop robotics, AI, have the potential to reduce or eliminate pesticide use, to facilitate field biodiversity, and to create rural entrepreneurship opportunities. Agri-tech provides all farmers, small and large, with the tools to be more sustainable, but research, technology, development, and entrepreneurship are going to be needed to put those tools in the hands of smallholder farmers. So thank you very much for your attention. On the slide there, there's a couple of references that if you're interested, where we've documented more of the analysis that I've talked about today. So thank you very much, and I look forward to your questions and comments.
Thank you very much, Professor Lowenberg-DeBoer, and thank you for opening up very interesting questions related to potentials of these new innovations and technologies, particularly these robots or robotics in crop, motorized particularly. Before I open this floor for questions and comments, let me pick up some of the cues that I got from Professor DeBoer's presentation. One is this, which comes to me very striking and very very potential and promising technology, is that the technologies that we have around us now have a huge potential of cost reduction per unit of your produce, be it wheat or maize or anything, by robots, especially the motorized robots, can be reduced very significantly. And we have seen in the graph that how this farm equipment cost curves can be reduced really with this robot cost curve from the conventional cost curve. That's a very significant observation. And the second thing is that apart from this cost curves, there is a human time cost involved on the part of the farmer. And as I understand that how this time engagement for physical labor can be shifted to more of management, then fixing up the proper strategies of farming, or finding out the more feasible marketing options. And then finally, also the processing part of it can be done from the farm itself. And then the third element is that this outcome, or let me put it the other way, the result of these cost-effective, time-saving, more efficient equipment services, say robots or VRT or any other thing, ultimately results in improved yield per unit of land. And for Bangladesh, it's quite important that with declining arable land, the continuity in yield improvement is very, very important. So with this few cues really, I would now like to open the floor for questions and comments from the participants. So please introduce yourself and then make your comments. You can raise your hand. Hasneen and Mahbub, you can help me if I miss any hand raised.
Sure.
Yeah.
Sure. At the moment, I don't see any hand raised.
Okay. Let me.
Dr. Saidul Rahman sir has raised hands.
Okay, Saidur. I can say Rana Masood as well. So Rana, you wait, Saidor.
Yeah. Thank you, sir, and thanks, Professor James, for his excellent presentation on sustainable agriculture, particularly for our small-scale agriculture in Bangladesh. I found many things really very interesting and very useful in the context of Bangladesh. Some of the things he made me clear, particularly he made the differences between precision agriculture as well as smart agriculture. That was very nice to me. 2-3 things came in my mind, particularly large-scale autonomous equipment is cost-effective, no doubt, but particularly for small-scale agriculture and for very poor farmers in our country, that will be really difficult to have those large-scale autonomous equipment. But you have also mentioned crop-specific or very tiny robotics also. So do you suggest, say, weed-specific or any particular weed-specific robotics for our agriculture? Something like that will be very useful at the initial stage. Another thing you have mentioned, robotic equipment can reduce cost, no doubt. But how about the productivity? Will it increase productivity also for organic farming? How it is related with that? If you give us a little bit thought about that, will be very useful. And one of the slides you mentioned, we have scope to use digital device for storage, drying, harvesting, fertilizer use, weeding, and planting also. So these are the potential area where we can use mechanized equipment largely in future.
Okay.
These are the things, if you kindly respond, we'll be happy. Thank you very much once again.
Professor Lowenberg-DeBoer, let me take one or two more, and then I will ask you to respond to, and then we'll go for a second round. Is that
Sir,
okay with you?
one more thing. Sorry, sir, I did not introduce myself. I am Dr. Saidur Rahman. I am a professor of agricultural economics in the same department where Mr. Alamin is working, and Professor Mandal is my supervisor and our mentor. Thank you.
Thank you very much. So is that okay if I take one or two more questions in this round?
Yes, go ahead. I'm taking notes.
Thank you very much indeed. Okay, Rana Masood, I can see.
Yeah, thank you, sir, for giving me the opportunity. At first, I would like to introduce myself. This is Rana Mohammad Masood. I am assistant professor at the Department of Agricultural Extension Education from Bangladesh Agricultural University, and I am studying at Niigata University to pursue my higher studies in Japan.
Are you joining from Niigata now?
Yeah, yes, sir. I'm from Niigata.
You are from Japan now. Very good.
Yeah.
Okay.
Okay. At first, I would like to thank Professor Dr. James for his highly informative and lively presentation regarding precision agriculture and different sophisticated agricultural technologies. Bangladesh is a small country, and most of the farmers of our country don't have the socioeconomic conditions to adopt this kind of sophisticated agricultural technologies, because at the initial stage to adopt these technologies, a high amount of initial cost is required. But in case of our country, it doesn't permit the socioeconomic condition of the farmers doesn't allow them to take this kind of risks. And most of the farmers have the traditional mind setup And I think this is the one of the major barriers to adopt this kind of sophisticated technologies. Could you please recommend any specific mechanism for the developing countries like Bangladesh to make this kind of sophisticated technologies more popular among the
Okay.
poor and rural farmers? Thank you very much.
Thank you. I can see Sohail Adnan is raising his hand. So Adnan, are you there?
Yes. Assalamu alaikum. Thank you very much, respected moderator, to giving me the opportunity. I feel honored and privileged to be here with you.
You introduce yourself. Where are you
yes.
joining from?
Yeah, I am Sohail Adnan, and I am currently residing in Japan. I am an IT professional working here in a multinational company, and also I did my master's from Japan last year. I also find this presentation is a very smart presentation conducted by the Honorable Professor James Lowenberg-DeBoer. Thank you, sir, for your wonderful presentation. And I find it very interesting if I find in the slide 4 and 5 regarding with precision, smart farming, and other technology, I quite find familiar with my research I did in last year for my master's, 2-year master's program. I did the same research, much more similar research regarding recognition of pumpkin flowers and position detection by the drone aerial image. So I was my research was identifying the yield management process during the pumpkin harvesting. So I took aerial view of in the pumpkin field by the drone. I use the advanced drone for Phantom 4 DRTK model. Then I took some aerial images and compare the manual pumpkin numbers with this drone aerial view. I tried to find out the yield process by the estimation of actual flowers and female flowers from the hectare field. And by calculating, we wanted to measure the yield forecast, because now recent time, human labor is a big concern, the shortage of labor, and the timing is also, of course, a big factor. So this the research actually wanted to find some findings so that we can reduce some human labor by these aerial view images. And my second part of the research was position detection by the Python, so that in the future, the robot, the automatic robot can pick up the pumpkins from the field. So I did the position detection from the by this aerial view. So I find this presentation very interesting, and which will contribute to the sustainable and precision of our agriculture in our country. And as I was a student of agriculture engineering in the Japan, so I find some similar research like boom sprayer, boom height control, and robot tractor harvesting system, which is very much related with IoT and GNS satellite system, which are actually minimizing time, effort, and contributing to automation and future Industry 4.0 regulation. So thank you for Honorable Professor James for your interesting presentation. I feel honored to be here with you. Thank you.
Thank you very much. Professor DeBoer, I think you can take these 3 questions up really, and then we'll move to the second round.
Okay, thank you very much to those of you who provided the questions. I will try to go through them step by step. The first question about smaller weed-specific robots. I think the vision here is that in order to make the manufacturing of the robots cost-effective, they need to be generic. And but those robots then would be equipped with AI and a learning capacity, so that, for instance, if we had weed control robots, that over time, those robots would learn more effectively to identify the weeds in a specific field or other pests as well, and then to control them more effectively. This may also create local business opportunities for companies and entrepreneurs to provide local training images for these generic robots. And yes, there's good evidence that robots will increase productivity, even the small robots, which may not move very fast. But it's important to remember that when robotics enter the picture, time is much less important than it is when the farm work is being done by human laborers. Number one, the robots can work 24 hours a day. They don't need rest breaks. They can work longer. So it may not be so much productivity over time, but certainly productivity in terms of work done and the cost of that work. There was the question from Mr. Rana Masood about the investment capacity of farmers and alternatives to that. And if we think about the first thing that has to happen in order for all of agritech and especially robotics to be applied in smallholder agriculture is for there to be lower cost equipment, and that's achieved partially by mass producing the equipment, but also they were large and clumsy, and it was not clear who other than a few very wealthy people would ever use them. But over time, you had companies like Nokia out of Finland that developed very small, very cheap cell phones. And so now you find people all over the world, including some very poor people, who now effectively use cell phones for their communications. To facilitate the adoption of the technology, because at first the technology may be expensive, the idea is to have some kind of contractor or rental situation, and Bangladesh has good experience with that in terms of motorized tillage, primary tillage, which now by and large is done by service providers. But cell phones and smartphones give those service providers new opportunities to better coordinate and better manage their machines. And so if we look around the world, we see there's a company called Hello Tractor, which started in Nigeria, which uses smartphones to collect the orders for various farm work and to better manage that. So there's lots of opportunities there to facilitate the adoption. Now, in the longer run, we don't know. In some cases, farmers will own the equipment. In some cases, they'll continue to use contractors. That's a very localized decision that depends on local conditions. But to facilitate the initial use, we see that. And then thank you very much to Mr. Adnan for the example of using drone imagery in pumpkin harvesting, and we see that drone imagery as well as using drones for input application is of growing importance all over the world. So I hope that has responded, at least in part, to the comments. So I look forward to the next round.
Thank you very much indeed. But before I your response to Mr. Rana Masood. Rana Masood probably tries to figure out that our farmers are by and large tradition bound, they are small, so cannot afford lumpy capital, or that kind of the conventional type of argument really. But then what we have seen over the last 20 years in Bangladesh, that you can get away with this in two ways. One is that not each and every farmer has to buy a machine or has to own a machine. We have had this example with shallow tube wells, the groundwater pumping device, that in the locality, just a small peasant farmer, in some cases the landless farmers, just took it up as a business to sell irrigation water at cost, beginning with crop share and then shifted to cash payment per unit of land or per unit of time or whatever. So that means that even if the machine is lumpy, actually they are not yet really, except this combined harvester. But Bangladesh has had a very, very promising example of dealing with this lumpy machine or expensive machine through a market really, which we call contractual service market or custom hire service, or as Professor DeBoer says, it's a rental market really. It's almost the same thing. Began with water market, with irrigation pump. And then the other way is that a huge number of local service providers really have come up really. Some of them have been financed by institutional banking loans, and some of them have their self-financing facilitated by this remittance money, not necessarily from abroad, but from the cities to the areas. So somehow or other, this service provision of the machine has emerged as a very profitable business, particularly for the educated or school dropout youngsters really, who have taken it up as a kind of business. And that is still going on, and that's the hope really. So with this, let me move to second round. I can see Muhammad Iftekhar Soban. Are you with us?
Yes, Dr. Mandal, I'm here.
Do you have any question or comment?
Yeah, just a few. Let me introduce myself.
Yes.
I'm here. I'm representing iFarmer, one of the agri-fintech companies in Bangladesh. So I have a few comments, and I will start with the last point you made, Dr. Mandal, is that there is a very big opportunity, or people are actually capitalizing that, the rental model. And we are trying to help on that, because we help the rural farmers on mechanization, on getting quality input, and also GAP, the good agricultural practices. So we do training and all those stuff. So we provide financial assistance for buying the machines. So we've been doing it for small and medium-sized machines. We are not doing for the large tractor harvester. They have been like subsidized by government, but still it's quite high, the cost, initial cost. But the middle ground like power tiller and other equipments that we finance, we provide the initial capital cost to them and they pay over time, let's say in 4 months or 6 months. Because farmers, their income is seasonal. So right now they need money for input and equipment. And then after 4 months, when they have their produce, they can actually pay back because they have the money at that time.
Okay.
The rental model is very, I will say this has very good potential. We have been trying to like teach some of the local entrepreneurs who is using the equipment in their own field and providing it as a rental to other farmers around this vicinity, like in the same village or even the other villages. So thank you very much, Dr. Mandal, for pointing out this very important thing. The next point I would make from Professor James's presentation, there are robotics. It must be a coincidence because last Thursday I was discussing with a few people and we have been discussing that we are falling behind. Actually, we are behind in mechanization. So because we are behind,
I am missing
now
you.
there is a change in the machineries. Like right now, the focus or the
Can anybody hear him?
I can't hear him.
Probably internet connection at his end is not good.
That's about. Okay. Yeah. Who was the Iftikhar?
We cannot hear him.
Yeah, we cannot hear him. Maybe let me shift to someone else. I can see Dr. Ashadul Haq with us.
Yes, sir.
Ashad, are you with us?
Yes, sir. Can you hear me, please, sir?
Yeah, I can hear you. Introduce yourself and then make your point, please.
Thank you, sir. Myself, Mohammad Arshadul Haq, Senior Scientific Officer of Farm Machinery and Post-Harvest Processing Engineering Division, Bangladesh Agricultural Research Institute, Bari, Gazipur. Thank you, sir, for giving me scope to say a few words. And I want to thank James for your nice and excellent presentation, which will be helpful for our Bangladesh scientists and scientific community, and also for the coming future farmer as well. Rightly, I want to acknowledge Sattar Mandal, sir. You said our farmers' motto. Actually, farmers' motto is to use as custom hire service, especially for the farm agriculture machinery. And another unique thing is for our country is a small machinery is most adopted than the bigger one. So I understand that much robotics could be adopted in our country if we can scale down in some aspect and could be validated in our socio-economic and soil environmental aspects. Otherwise, maybe or may not be, we could disseminate the imported robotics in our field condition. So this is very good initiative to increase the knowledge bank of our scientific community. But I think we need to work more to develop some technologically sound man behind the machine. Though we are talking about the machine without the man, but I believe for the robotics or the precision agriculture, we should have some trained and technologically sound scientific and operator type manpower to sustainably execute such type of technology for our country. That's why I want to thank your initiative, and I want to request from Bari authority, since we are developing some small sorts of machineries, if we can work together with Bari and expert from abroad like James, we can develop some prototype for our farmers, which could be recommended for the adoption or could be validated. Thank you, sir, for giving me floor. I hope it will create a new venture for the future research. Thank you very much, sir.
Okay, the only point that I would like to pick up from your contribution is that it is not necessarily true that farmer always prefer the small one to larger one. And the classic example you have seen, Dr. Arshad, is the two-wheel power tillers are being increasingly replaced by four-wheel tractors. And the manufacturers around the world have got this message, and they have also shifted, as far as I understand, the manufacturing of the four-wheel tractors and maybe unmanned sensor-based tractors. That's a good. So thanks for your interest and then pointing out Agricultural Research Institute's priorities. Really. Thank you.
Excuse me, sir. Mr. Iftikhar seems to be back. Would you like to hear from him?
Iftikhar, do you have any last comment? Anything left? Then join right now. Iftikhar?
Please unmute yourself, Mr. Iftikhar.
Yeah, thank you very much.
Yeah.
My apology for dropping out.
Make your point quickly.
Yes, sir, quickly. So what I see is for the mechanization in our country, we are still dependent heavily on imported equipments, which sometimes is not preferred by the farmers. Like there are small problems like the wheelbase is too wide, or when it is planting the rice, it is making it too thin or for the thing. So what I believe is we have a very good light engineering industry in our country, and they can do wonders. But what they lack is they don't have the R&D, research and development budget, or they don't have the study mentality or other things. So if there is an effort to do some research, especially with the farmers, so they can understand the deficiencies in the existing machineries, and they can create like a design or blueprint from them and make it available to all the light engineering people or even the heavy industries also. So if there is a national level of initiative regarding that, it can be very helpful, sir. Thank you very much, sir.
Just to add here before I forget, is that, you know, in last March this year, we had the CIMIT Bangladesh conference. I don't know whether you were there or not. So we had a lot of discussion about the possibility of local manufacturing of agricultural equipment. The Bangladesh big companies or initiator like SCI Limited, and then Metal, and then Alim Industries, all these pioneers are there really. And I think Bangladesh Agricultural Research Institute, which Arshadul Haq is representing right now, also showed interest about it. So it would be very nice for you or any organization like you really to come in touch with them and talk to that how we can proceed. Financing is one thing, but that is the easiest type of solution really, that you need money, you ask some money, you get it or not, that is a different issue. But more difficulty is that what you want to do actually, which will give you the scale of production and then have enough of potential market to sell those equipment at a profitable margin, or that kind of issues are involved. So please don't lose your passions and get in touch with this mainstream government or private sector organizations. Thank you. I would take one more really before I move on to Professor DeBoer. Who is there? Is there anybody?
Yeah, hello, sir. This is Mohammad Ashraful Alam. I am representing the Managing Director of G Agro Limited. So I have two part of the question or comment, you can say. Thank you for organizing this webinar. And basically, I'm not in this field. I'm basically an engineer. I have a consultancy firm which is serving the building design.
Can I see your face? Sorry.
Yes, sir. Yes, sir. Yes, sir. I hope, I don't know. Okay, sir. So basically, recently we added in our consultancy design, consultancy services, some drones. So we are looking some opportunities to work together for, collecting data. G-Agro, let me introduce another thing. G-Agro is basically a service where we are trying to introduce the traceability and the agriculture information system. So this is one thing that we have started. But recently in our consultancy firm, we added few high-tech drones where we can collect lots of information of agriculture production and climate change things. So my question is to Professor James that in our country, though we have not started any kind of technological innovation in agriculture, but can you just share your experience if we can utilize this kind of technological interpretation in the agriculture production? What additional amount, you can say it in ratio or percentage, people can have by incorporating this kind of advanced technology? So this is to you, and another sir to you, and particularly everyone who has been initiated this thing. So can you just add or initiate few more program where people like engineers, innovator, entrepreneurs, financer, I can see lots of people who wants to invest in agriculture, pure safe agriculture. So as you are contributing in our country in agriculture sector, agriculture economy, and I think you should initiate something where all people can come forward and make something different and a combined effort. So I hope that you'll definitely invite other people as well, like you invited us. Thank you for your time, sir.
Thank you very much. I take your kind suggestion. BAU, Singh, and then CIMIT. CIMIT stands for, International Center for Wheat and Maize Research, whose headquarters is in Mexico. So there is a collaboration between these two institutions. So I would certainly convey your suggestion to BAU and CIMIT colleagues, really, so that there can be a kind of regular dialogue or assessment in this private sector. As a matter of fact, Ashraf, we are looking for this kind of interest really from now. I'm very glad that you have expressed yourself. Okay, before I move on to Professor, Nahid Sattar, are you there? Nahid?
Yes, sir.
Okay, please make your points quickly and then I'll move on to Professor.
Yes, thank you very much, sir. I'm Nahid Sattar, Associate Professor in the Department of Agricultural Economics. So first of all, thank you to Professor James for the presentation he made. I think the point about we of course need advanced machinery for sustainable intensification. And of course, I believe that eventually they will come. Eventually, we will have more adoption and more of such machinery used in agriculture. However, I think the small plot sizes we have it does remain as a limiting factor in cases of some machinery, some heavy machinery and some technologies. So my question is should we expect to see the adoption of certain plot size neutral technologies, for example, use of drones or small robotics or GIS to be more faster as opposed to say some large vehicles or such sort of technologies? So my guess is there would be different trajectories or pathways of adoption of different types of advanced machineries and technology. So what would be your thoughts on that? So that was my question. Thank you.
Thank you. Professor Lowenberg-DeBoer, I move on to you for your response.
Okay, thank you very much, Professor Mandal, and I will try and hit the high points here. First of all, to respond to Mr. Sobhan, indeed, there is a great potential to develop a local industry in terms of producing some of this equipment or accessory services. So, for instance, if we're talking about training the artificial intelligence, there's a great need for images and so on that would be used to train the vision. So there's important role of working together to build up that local industry. And then to respond to Dr. Hauk from Bari, that I agree absolutely that there's a need to train people who would work with the robots, and that's part of that is the technicians who would repair and maintain the robots, but even the people who work with them daily would need to know certain things. And right now in Britain, we're working on a code of practice for mobile autonomous farm equipment. And a big part of that code of practice is what kind of training is needed for the supervisors of robots. What should they know? And the opportunities there to collaborate with institutions and individuals worldwide in developing prototypes and so on is very, very substantial. Mr. Alam asked mainly about examples of increase in yields or profitability or costs. And that varies a lot by country and by crop. So it's almost impossible to give a global number, but we know that in specific places, the profitability or the cost has been increased quite substantially. And we know that overall, and the chart that I showed you at the beginning indicates that overall the whole world has moved from a case of using more and more inputs, more and more land, labor, pesticide, seed, so on, to a pace where we're using those equipments better for increased yield. The question of speed of adoption of small equipment and particularly the swarm robotics idea is a very, very important one. One of the big issues here is that the big farm equipment companies, so the John Deeres, the C&H, the AGCOs of the world, are very happy with their current business model and their current clients, and they're not always interested in serving the millions of small farmers around the world. What we need are entrepreneurs that realize the possibilities that this could be a very profitable market for someone, and probably more than one someone. But it really needs entrepreneurship to develop the kinds of technologies and business models that will serve those people. And if that happens, then the adoption will be very, very rapid. But it's unlikely that the big farm equipment companies will produce the kind of technology that small farmers in Bangladesh need. So thank you very much. Great comments and questions.
Sir, I think you're on mute. Can you please unmute?
Sorry. Thank you very much indeed. I see two more hands before me. One is Abdul Jalil, the other one is AKM Abdullah. Abdullah, I hold it on for you for some time, but Jalil, Abdul Jalil, are you with us? Jalil?
Yes, sir.
Can you make your point, Jalil?
Yes, sir. Thank you, sir, for giving me the opportunity to test samples. So this is MD Abdul Jalil, and I'm pursuing my graduation at Bangladesh Agricultural University under the Faculty of Agriculture. So first, I'd like to congratulate Professor James for his excellent and nice presentation. So I got most of the questions answered. So I have a couple of questions. Like, as you know, our farmers community are mostly illiterate and poor, so they don't have minimum knowledge about how to operate the machinery and robotics. So how it could be effective in the context of Bangladesh? And as you know, our unemployment problem is very much in Bangladesh, and how we can replace it and we can solve it by establishing machinery. And is it eco-friendly? That was my questions.
Okay, very good. Thank you. And Abdullah, are you with us?
Yes, sir.
Okay, Abdullah, I'm very happy to give you the floor now. You have been so helpful, and I'm very pleased to see your nice face after so many days and years, really. And I hear so much about you, and then I have read some of your writings already. Thank you very much indeed. Abdullah, go ahead.
Thank you, sir. Actually, I have no specific questions, but I want to add one questions to James. But if James permit me, I want to supplement few thoughts as like the answer of few questions, because I brought up in a farm family in Bangladesh, and I read about agriculture, so I know the context. I think I can add a few thoughts to the process of automation in Bangladesh. Could I?
Professor.
Yeah, James, could I supplement few things with your answers?
Yeah, go ahead.
Please accept my apology. Yeah, the first question I want to ask you: how demographic dividend could be capitalized in agri-tech for Bangladesh? You know, we have 33%, approximately 33% youths. So how agri-tech could bring these youths in the umbrella of agriculture? Because this is the challenge for Bangladesh, to create employment opportunities, mainly the educated people. The educated people are mostly the unemployed people, and this scenario is adding more vulnerability in our country. So that is the point. Now, regarding the overall sessions, I like to thank our department head and Sattar Mandal sir for arranging these sessions. And it's really pleasant to have my colleagues and my present mentors, Professor James here. Actually, I'm working with James, so I regularly raise questions to James. So that I'm not asking questions to James, but I want to make simple for Bangladesh automation, because we have some thoughts or orthodoxy that the automation, something like more sophisticated, cannot be implemented. It may be the drastic change of the overall farming system. But my understanding working with James and the hands-free hectare is different. The thing is that when I was started my PhD program, I was knowing nothing about precision agriculture. Precision, PA terms is totally new to me. But I found this enjoyable just traveling with James, because he make me more friendly, more enjoyable research scope for me. So I'm viewing automation for Bangladesh in the scenario like that. Bangladesh have some technologies in hand. They are doing some work with mechanization with human labors. So how Bangladesh could introduce automation? There may be two options. One is totally new robots, another is retrofitting the existing technology. My understanding, we need research But my hypothesis is that just to retrofit the existing technologies, we can easily automate our farming scenario. We can easily facilitate our government prudent policy initiatives like Digital Bangladesh, My Village, My Town. What we have to do? We have two-wheel tractors. So I visit different sites in, for instance, China, Japan, to see what technologies are available to retrofit these existing two-wheel tractors. For instance, Alibaba have some retrofitted kits. They are selling these kits. I visited these kits, these sites to check how Bangladesh could automate. If we get this retrofit kit, which hands-free Hector at United Kingdom is doing, we can easily install this retrofitted kit with our existing systems, so the cost effectiveness can be achieved, and we can easily attain the cost effective issues. And another concern here is the small fields. When we think about mechanization, it seems that small fields are not feasible. For United Kingdom, we found that small fields are feasible with autonomous machines. For instance, we did 1 hectare field. We incorporate 1 hectare field in our models, and that was intention of mine and James to link with Bangladesh, because we have approximately 1 hectare field. So if 38 horsepower tractor is feasible for UK in 1 hectare field, why not we can think about 12 horsepower two-wheel tractor? We can easily retrofit this 12 horsepower to a tractor for planting. For spraying, we can just add the booms in the same tractor. That is the point. And I think it's not like that we are quite far away from automation. Just it's our mindset. We need some changes. We need some initiatives. So a simple demonstration can make the change in Bangladesh. These are my thinking. Thank you, James.
Thank you very much. How many? We have Jalil, and then we have AKM Abdullah. Is there anybody else? Mahbub Hussain, do you want to pose any question?
Yes, please. If you allow me, sir.
Please go ahead. Go ahead.
Thank you, sir. First, I would like to thank Professor James for his nice presentation. I thoroughly enjoyed it. I have a very specific question to James. From your presentation, what I have understood that farmers having robotic machineries have the cost advantages. So I was a bit curious about the context of this analysis. For instance, like any other machineries, I suppose there would be elements of depreciation and time dimension of using robotic machineries. So while you calculate or while you estimate those costs, and did you take into account those items? I mean, depreciation cost, and would there be any maintenance cost as well over time? So did you take into account all these things? Thank you very much.
Excellent. I think let me move on to Professor James DeBoer really for third round response.
Okay, well, thank you, Professor Mandal. First of all, the question from Dr. Jalil, how can illiterate and poor farmers learn to work with this kind of equipment? And the main thing I would do was to remind you that already many illiterate and poor farmers work with quite sophisticated equipment. Many of them have cell phones, which are really very sophisticated bits of equipment, but the engineering has made them easy to use. But specifically in the agricultural setting in North America, on large farms, many of the farm workers are recent immigrants from Mexico and Central America. Many of them are also illiterate and not very well trained, but they use GNSS guidance equipment all the time and use it very effectively. So in part, this is an engineering problem. How do you make the technology easy to use? And then there is, in the longer run, an educational and training component to that. Then coming to the comments from Mr. Alamin, agritech can be a way of creating good employment in rural areas. And we've talked about some aspects of that already in terms of the maintenance and the training of robots, but probably even more than that, it's using the capacity that new technology provides to produce the food and other products that are demanded by consumers. So the entrepreneurial opportunities are there that would provide for them, for those younger farmers and younger entrepreneurs, an ability and a lifestyle that would be preferable to that in urban areas. If we think about how to introduce automation, I think the retrofitting idea will be very important for a transition period. Certainly in Britain, it will be very important until autonomous equipment is allowed on public roads, but it also facilitates that transition because farmers are already familiar with a certain kind of equipment, and if you can retrofit that, that becomes easier. But in the longer run, it will be new, specifically designed equipment. Then to come specifically to the question from Professor Mahabub, that yes, the approach to the economic analysis uses sort of standard equipment economics. So depreciating that farm equipment out over a period of years. One of the advantages of the hands-free hectare approach, which used retrofitting conventional equipment, is that we understood what the maintenance costs of that and what is the durability. How long will that kind of equipment last? What is the useful life? And so on. So the retrofitting actually made those economic calculations easier than they would have been in other cases. So thank you very much for those comments and those questions. I think it's been very, very insightful. Thank you, Professor Mandal.
I do have few more minutes really before we wind up, Professor.
I do have a few more minutes. I do have another meeting coming up, but I do have a few more minutes.
10 minutes? No?
Yeah, 10 minutes.
Okay. If there is no other intervention, let me then begin to wind up. So is there any other contribution which you feel that you should make it right now? Very welcome.
Sir, at the moment, we don't see any hand raised.
Excellent. No problem. I think we have had a very wonderful session with Professor Lowenberg-DeBoer. So I would like to highlight a number of points which are in a sense complement or supplement Professor's comment already or responses. One is this, let us not forget or underestimate, or let us have a full knowledge about these local service providers that have emerged in Bangladesh as a kind of new breed of entrepreneurs, really. They are not very rich. They are not very highly educated, but what they have all these business kind of mindset, really. So they have come up. So that's the basis of Bangladesh's really progress or future plan to go ahead with digital agriculture, to put it very precisely. The second thing I would like to put forward is that there are inhibitions in the government policy level about a number of things. One of the things that I would like to highlight is that there is a demand from some business cycles, business community, for allowing them to import liquid nitrogen fertilizer. But the government has not had yet made any decision about it. One of the reasons they don't do, because they think that for liquid nitrogen, they will need to use drone. And drone is not under the Ministry of Agriculture's control. Drone is under the Defense Ministry. So if there is any question of using drone commercially, then you have to fall back upon the Defense Ministry, which is a little bit difficult job really. So still there is a kind of indecision. But today I hear, if I have understood very well, from Professor DeBoer, that there is on the horizon, or still on the field, that on-the-go sensor for nitrogen really. And that on-the-go sensor seems to be so handy. I have not seen it, but I have seen it in the picture. That is so easy to spray nitrogen wherever it is, and very sensitive also. But then the professor's concern is that it's expensive. It's about $300 per unit. But then I understood also, as a simple economics, that as the unit of production goes up, with the higher rate of adoption of this technology, then unit cost of price will come down. And I think I hear something like it may come down to $10 even really. And if it comes down to $10 for any such machine, it's not that expensive in Bangladesh context at all. I echo Professor DeBoer's comment that in Bangladesh, even the literate and the farmers whom we call very poor are using this smart touch phone, either directly or through their children, which cost them 15 to 20 US dollars right now, and they're buying it. And the prices are also coming down because there are many types of manufacturers are now coming. Even Bangladesh is manufacturing or is going to begin manufacture of these mobile phones or anything, but who knows that Bangladesh will come up or then other people will come up. So cost per se is not that a determining factor at the moment really, to my mind. Then the capacity. I think if I understood Abdullah, then I have this point that if there is 38 horsepower, what they call tractor? No, robot tractor. Why not then we try 12 horsepower or anything? But Abdullah, your point is valid, no doubt, because we have small fragments and parcels of land. But even in that condition, the 70-75 horsepower combined harvesters are now working, and their numbers are now about 5,000 in Bangladesh. And then the very classic brand of Yanma. the SCI company are using it really. And about half of them are sensor based already. So this capacity is one thing. Yes, if you see directly, then yeah, only one plot, it doesn't mean much really that the machine cannot run. But since I have seen also in my own research that we call operational consolidation of these small fragments to an economic command area done by the local service provider themselves through a contractual fashion, that this small fragment of one farmer does not in any way stand as a hindrance to move out to another farmer, probably 2 plots away from the present one really. And they have their own mechanism of consolidating for operational purpose without doing anything with the ownership or titleship or tenurial status of any land really. So this is a wonderful kind of opportunity that has been created through these local service providers, very innovative business ideas thing. My last point would be like this. Abdullah drew your attention to demographic dividend, and he mentions about 30% of population of rural youths really, who are educated, half educated, or have some level of education. Quite fine. Only one thing which is needed probably is the numeracy, not the literacy per se. It's a numeracy, whether or one can keep some simple accounts and can read numbers really. And then it's fine. And that reminds me, Professor Eric Clayton's of Y College, London University, where I studied in the mid-70s. And in his research paper from Kenya, he showed, I still remember, that how these four-wheel tractors in Kenyan agriculture attracted the rural unemployed youth really to take up this tractor operation, and partly with the tractor services and marketing as a kind of very profitable kind of employment. And in the mid-70s, that was very attractive to these young people. I think I can see manifestation or replication of that kind of picture in Bangladesh. Usually a rural youth wouldn't go to do farming with traditional plowing or anything, then do no longer exist. They do not go to harvest their crop by hand sickle or anything. But once they have a reaper, walk behind reaper, or a harvester, or a thresher machine, they immediately make the band or change their mind to take up that as a business. Still they are on farming, but it's a high gear, mechanized type of farming they can boast of really. So this rural youth can be engaged in 3 types of business, to my mind. I have seen that in my own work. One is this direct operation of these machines. The other one is this distribution channel that they work in, like dealers, like some of them would be importers and other things. And then the third segment will this rural mechanics services. And we have about 1 million rural mechanics are working in Bangladesh really, fixing up these irrigation pumps, fixing up these 700,000 power tillers and tractors, fixing up this 5,000 combine harvester, and there are many, many millions of small machineries really. And a part of these rural mechanics working in the local workshops really are also working as drivers to these machines really. So it's a huge, what do I call, a backward linkage and forward linkage really to a machine really, which creates employment. So with this, let me conclude here, thanking you, Professor Lowenberg-DeBoer. You have been so kind But before I finally say goodbye, do you have anything to tell us, to our colleagues or students? Any message?
Only that there are tremendous opportunities in agri-tech everywhere in the world, and especially in Bangladesh. So I look forward to working with you in helping to realize that.
Thank you very much indeed. I appreciate, and will be in more of this kind of academic interactive sessions, if you kindly volunteer to join us, because this wonderful virtual technology has opened up enormous opportunity for us as well.
Yeah.
That we don't have to travel, we don't have to spend money to travel and fly, but we can do the more or less the same thing. So thank you very much indeed, Professor, and thank you very much, my dear colleagues, my students from all over the world. We had quite a number of our distinguished participants from outside Bangladesh, from UK itself, and then from Japan and from Europe. So thank you very much indeed. And with this very satisfied mind, I would like to switch over to Professor Hasneen Jahan, the chair of this session, to finally conclude and then finish. Thank you.
Okay, thank you very much, sir, for conducting this session very effectively and interestingly. I would like to take this opportunity on behalf of myself and from my department to thank Professor James to wonderfully present a very interesting and informative presentation to us. We have learned many things, especially from economics point of view, like those robotics and this precision agriculture and this digital agriculture. These things are quite new to us, so we have learned many things, and it is very interesting and very like we are pleased to know that this is also very cost effective. These technologies are from the economics point of view. So I would also like to request Al-Amin, if possible, use some data from Bangladesh to do the feasibility test to the opportunities and potential of using these technologies in Bangladesh. From Bari, they offered you to some demonstrations. We would also like to supplement if you need any helps, and Professor James' guidance obviously will be there. So there are lots of things to discuss more. It's just opened up the window to discuss. So this is not the end. I think this is the start for us. So we'll continue further to discuss the potentiality, discuss the opportunities, and the opportunities to work together, and from especially how Bangladesh can use these technologies that you have been applying in the developed countries like UK and USA. So I welcome you in Bangladesh, either virtually or in person, and to collaborate with us in future. We like to take the advantage of your expertise, and would like to use this in our country. So in these few words, I would like to thank you again for being with us for a long time and giving us so many thoughts and informations in this new field. And I would also like to thank Professor Sattar Mandal sir for always encouraging us and supplement with many new thoughts and arguments that we are learning continuously. And there have been like around 60 participants in the webinar that enjoyed your presentations. This is the, so I would like to thank each and everybody who have participated, who have commented and gave their valuable suggestions and comments and shared their experiences. So I thank all of you to be here with us today. So thank you, Professor James. Thank you, Sattar Mandal sir. Thank you, Alamin. Thank you, all of the participants. So in the viewers, I would like to end today's session. Thank you very much.
Bye-bye.
Bye.
Thank you and goodbye.
Goodbye. See you next time.
Thank you.